So we can see now that the lower potential indicate iron half cell. So the iron half cell will be an anode, while the tin half cell will be a cathode in our galvanic cell. So we just need to write, we just determine the cathodes and the anodes, yes, the cathode and the anode in this galvanic cell. What else do we need to do? Determine the direction of electrons flow as well as cell configuration. Okay, and of course what reactions proceed in the cells containing following half cells. Okay, so maybe let's at the beginning let's try to write a scheme. Yes, the scheme of this galvanic cell. We have iron cations, iron half cell. Half cell will be of course anode, and we have tin half cell, and tin half cell will be a cathode. Okay, so what else? We can just write, we can draw how such a galvanic cell will look like. Yes, so we have beaker with iron, we have connection with our energy consuming device, we have metallic tin, they are immersed in electrolyte solutions, metallic tin in the electrolyte solution containing thin cations, iron cations, metallic iron, which is immersed in this electrolyte solution containing iron cations. Of course, both of these electrolytes are connected by a salt bridge. Iron half cell is anode, while tin half cell is a cathode. Yes, so we have the figure. We have here image of this galvanic cell. What about the electron flows? Of course, electrons flow from the anode to cathode. So from metallic iron to metallic tin. What about the half cell reactions? In the case of the anode, we have oxidation of iron. We are obtaining iron cations and 2 electrons, which are consumed in the cathode structure reactions. So tin cations consume these 2 electrons, and there is a creation of the metallic tin. Overall reaction: metallic iron plus tin cations give us iron cations and metallic tin. As you can figure out, the mass of the metallic tin increase, the mass of metallic iron decrease, the concentration of the iron cations increase, and the concentration of the tin cations decrease. Okay, so let's see the B example. However, I think it's very easy for you. It will be easy. So maybe we will move to the next example. I mean example C. Okay, so here you can see that we have two different types of the half cells. Yes, we have metallic type half cell and non-metallic. Here we have gaseous half cell. It's a hydrogen half cell. Yes. So let's try to draw a scheme of this galvanic cell. Yes. Firstly, we need to find out what half cell will be an anode and what half cell will be a cathode. Let's look at this table with this half cell standard potentials. Okay, we know that the potential of the hydrogen half cell is equal to 0.